Hey guys, it's Jessie. I told you I would post a video to help you with Lab 7, so here it is. This really does not cover the activities. This more is to help you with the calculations and your lab questions. The activities, I feel like they're pretty good here in the manual. I always recommend that you read through them a couple of times before you dig in so you kind of know what's happening and what's coming next. And the trickiest piece of this really is creating that monolayer. And there's a video to help you. There's a link here on the bottom of page 8. So be sure you watch that video about your monolayer. And again, I'm going to talk you through the concepts, some of the equations, and your calculations. And really, I'm going to cover exactly what is presented here on pages 5 and 6 of your manual, but I hope that hearing me talk through it will be helpful. Okay, let me get set up. Okay, so we are going to build a little corral out of string and fill it with an individual layer or a monolayer of stearic acid molecules. Okay, they're all going to line up. And if we can figure out both the number of molecules in our corral, molecules, and the number of moles, then the number of molecules per mole is Avogadro's number. Oh, I hope you guys enjoyed the mole song. Okay, so the number of moles, we're going to figure that out because we know the concentration of the stearic acid. We were given that. It's 0.1 grams per liter. We also know the volume of the stearic acid required. We determined that experimentally. It's how much stearic acid we added into the corral. So I'm going to use an example here. That's 0.53 milliliters, but again, you'll determine that one experimentally. We also know the atomic weight. That one is also given to us. It's here in our lab manual, and it is 284.5 grams per mole. So I can figure out the mass because I have the concentration and the volume. And from there, I can get the number of moles because I have the atomic weight. So let's walk through that. Mass is equal to the volume times the concentration. 0.1 grams per liter, which we will convert into milliliters. Nope. Liters on top, so I can cancel them. And I used 0.53 milliliters of stearic acid. Okay, now I can cancel my milliliters. And I'm looking for my mass. I'm in grams, and that's what I love about dimensional analysis is if I know I'm in the right units and I can plug this into my calculator correctly, then I'm pretty sure I have the right answer, which is 5.3 times 10 to the minus 5 grams of stearic acid. Okay, from there I just use my atomic weight. I know it goes on the bottom because I have to cancel my grams. The denominator of the denominator becomes the numerator. And I have 1.86 times 10 to the minus 7 moles of stearic acid in micra. Okay. Now let's calculate the number of molecules. We do need to do a little geometry. Here we're going to calculate the area. Oh, excuse me. The area of our circle and the area of each individual molecule. And then the area of the total circle over the area of each individual molecule will give us the number of molecules. This one is given to us in the manual. It is 20.7 times 10 to the minus 16 squared centimeters. The area of our circle we can calculate because we measured the circumference of our circle, which was about 100 centimeters of string, which is our circumference, or 2 pi r. From here we can calculate r and get our area. Okay, so r would be equal to 100 centimeters divided by 2 pi, or 15.9 centimeters. So it's 100 centimeters around, that's our C. And from here to here is 15.9 centimeters, that's our R. And we can use that to figure out the area, because area is equal to pi r squared. 15.9 squared times pi, 794 centimeters squared, is the area of our total circle divided by the area of an individual molecule. Gives us the number of molecules, which is so now if we just divide that by our number of moles, which was 1.86, we have our estimate of Avogadro's number as 1.95 times 10 to the 24 molecules per mole. Okay, so there's our experimental determination. If we figure out our percent error is always what you determine experimentally, the difference between that and the theoretical, or again, actual value, the absolute value of the difference between those two divided by the theoretical. So 1.95 times 10 to the 24 minus the actual value for Avogadro's number, 6.02 times 10 to the 23, divided by 6.02 times 10 to the 23. And you'll find this is actually a very high percent error. It's 224%. Hopefully you'll get a little closer, but maybe you won't. There's a lot of opportunity to introduce error in this experiment. Think about that as you go through it. That's one of your lab questions. And let me add that the only difference between this one and activity 2, it's the exact same set of calculations, except instead of a flat area, you have a 3-dimensional volume. So be sure to use the information provided here on page, what is it? Page 6 of your manual. Okay, you'll need your density of aluminum. There's your volume of a sphere, atomic mass and atomic radius. So again, it's exactly what we just did, except you have a volume instead of an area. You guys reach out to me if you have questions or concerns. I hope these are helping. Okay, good luck.